Hello all. In this video, we're going to see the first experiment, which is exploratory data analysis, where we do many kinds of data analysis, such as uh, clear describing the data, seeing the data, and exploring the data. Mostly, it contains all about exploring the data. So let's dive in ahead. So we import the necessary libraries, and then we load the data set, and we find the head value, which is we're having first five values as the head, and then we display the number of rows and number of columns in the data set, and we print the number of categorical columns and the number of numerical columns, and then we describe the data set. Describe the data set means it describes the statistical inferences of the particular data set, and info is all about they give about which are not null, which are the columns, which are the data types of those columns, and yeah. So and next we display the min, max, and mean of each of the numerical columns by using aggregate of function, which is the built-in function, and then we use and we explore data by taking a fine number summary for the column each, and we're displaying the box plot, and then we're displaying the row index and finding the quantiles, 25% quantile and the 75% quantile, and then we display the row index and we outlier the z score. So this is the box plot we have, and these dots are the outliers, and then we take the correlation of from the input features, columns age, price, tax, quarterly tax, rating, and next we just go over to where we display the feature pairs with a single highest positive and negative correlations. So what do? We unstack the correlation matrix, and then we take the top position pair, top positive pair and top negative pair, and the top positive value and the top negative value, and we display the highest negative correlation, and we display the feature pairs greater than 60% of it, and we analyze the statements about the skewness in the distribution of tax in the tax column, and we performing univariate for categorical variable with the number of observations, and then we use violin plot and swarm plot to perform univariate analysis. So both of the plots have taken the column rating, where as you can see, there are swarms of points, and in violin plot we see how much the data has spread in the column rating there, and then we use the scatter plot between tax and cogs. So as you can see, when tax increases, the cogs is also had increased, and then we perform bivariate between gender and age with the use of a box plot, and then we use a bivariate analysis to compare two categorical variables, gender and customer. So in this the visualization of the count plot, we see that how many female members are members and how many female members are normal members, and also for male, as you can see there, and we do a multivariate analysis between input features, all of the input features, and we display it and visualize it in the form of a pair plot. And then we go on to part B, which is the data pre-processing. We pre-process the data, and we first identify the null values and null columns here and the percentage of missing values. So after finding the missing count, it's there are four missing count in the branch and the product line 18 and the quarterly tax 4, and the missing percentage is displayed as such. And then we do the mean imputation, where we fill the null values with the average of the highest column, and then we get the imputation data, and then we do mode imputations, and then we drop columns which are having 10% missing values. So as you can see, after dropping columns there were 51 rows and 15 columns, and after dropping columns 51 rows and 14 columns, one column was dropped, where the one column had the 10% missing values, and then we're dropping rows based on z score, where you can see we dropped rows. Before dropping outliers, we see that there are 51 rows and 15 columns, and after dropping those outliers, we find that four have been dropped. Four rows have been dropped because of the z score is greater than 3. And then we find the percentage of the duplicates, and then we drop those duplicate rows, and we have only two rows where the two sorry, we have only 49 rows. Before there was 51, and after there was 49, so two rows were dropped. And same, we see the subset duplicate percentage, and we perform the min max normalization, and we plot it using a scatter plot, and then also z score normalization, and we label encode it finally. And we finally got one hot encoding for the feature payment. And these are the kinds of